Hi everyone. In today's video, we will see a powerful concept in software architecture design known as the event bus. So if you have ever wondered how different services of a really complex application communicate with each other without being tightly coupled, that is being decoupled, then event bus is an answer of a variety of answers that might be possible. So before we proceed, we need to understand what an event bus is. So if I am to summarize, if event bus is like you can imagine it like a central hub that helps us to enable communication between different components that are present in the entire system, right? So this is like a communication system that allows different services to pass information in a very decoupled way, so that instead of directly calling each other, we can just communicate through the events present in the event bus. So let me just show you on a really high level overview about the event bus. So let me just remove it. So let me just draw. Where is the paint tool? Yeah. So you can imagine it like something like this. Let's say this is the event bus, right? So you might have heard of bus topology, right? In networking. So event bus is like it holds a similar principle. So this is the event bus, and there can be different events, right? So let's say this E1 event. This is okay. How do I change the size? Anyway, so let's say this E1 event, this is E2 event, this is E3 event, and let's say this is a click event, right? This is another click event or something else. This can be another event. So what we can do is we can establish a publisher, right, which will push these events into the event bus, right? And similarly, we can establish several subscribers that will fetch the events from the event bus. So let's say there is an event E1. Let me just clear this up. Right. So let me just show you an example. Imagine this is the event bus, right? So let's say this is the event bus, and there can be several publishers. Let's say this is publisher, which is publishing an event E1 into the event bus, right? Let's say this is a click event. A button is clicked, and this is the event for the same. And I have the event in the event bus. And let's say I have an application that I want to display something with respect to this event, right? So what we can do is we can establish a subscriber which is subscribed to this particular event, right? Which means if anything new happens with this event, the subscriber will be called, right? So this is like a notification system that states that the subscriber here will be notified if there is an event E1. So if it seems confusing, I will show you a diagram right now. So I have made a small diagram for your understanding. So as you can see, this is the event bus that I was talking about, and these are publishers which will publish events to this event bus, and there can be subscribers that can get the event with respect to the one that I subscribed with from the event bus. So as you can see, we are not directly communicating with this publisher here, right? When we are decoupled here, we are just communicating via this event bus, which means I can also add another event, let's say event 3, and the publisher is P3. I can publish the same, I can publish another event E3 here, and I can, make another subscriber here S3, which will be subscribed to this event E3. So as you can see, this is very loosely coupled, which is really needed in a complex software architecture, right? So but before we continue, we need to see how we can implement this event bus, right? So here is a small diagram for you. So an event bus will consist of these three things typically, and importantly these two things, right? So it will contain an unique ID which will represent the, let's say, which will uniquely identify a particular event that has been pushed to the event bus. It might also contain the type of the event. It might be string or and so on and so forth. And we also need a map, right? So the map will basically determine the particular handler that will be triggered when we get that event. So don't worry, I will go through and I will implement the same, and you can just understand it well in the code. So for now, you can map this diagram in your head that we will implement an event class which will be having unique ID and a map which will be mapping the event, that particular event. Let's say we have an event named cart, right? And this event will be mapped with a handler named add to cart, something like this. So you can just imagine it something like this for now, and I will show you in the code. So let me just create a new file here, maybe like eventbus.js. And as I said, before we continue, we need to check some terminologies that are associated with this software architecture concept. So first thing that comes to my mind is, let me just write it down, is publishers. And just so you know, as you might have guessed, this is a pop-up system. This is a pop-up design pattern that we are using here. And publishers are like the components or the modules that trigger the events, right? They can be services that are associated, and similarly, there will be subscribers. So as I said before, if I want something to get notified when the specific event occurs, I can subscribe to that event. So there are subscribers, and the most important thing is the event. So event can be any change that is needed to get communicated throughout the bus. So event will be carrying the data to the relevant subscribers, because subscribers are subbed to the events, and publishers will publish the events, and event will be associated with these all. So let me just note down some benefits that are associated with this system, with this event bus. As I said before, the first thing is the decoupling of different services, as I said before. So it is easier to manage and maintain, and also it helps to reasonably scale the application, right? And it also leads to flexibility. So you can if I want to give you an example, a real world example, it will be like a user authentication system. So when an user logs in, there can be several services that are actively working on, right? So some might be to display the profile picture, some might be to display maybe something personal to that particular user, and there can be real-time notifications. So event bus helps us to decouple these components and helps us to manage these in a better way. So I'll be showing you an implementation for event bus, and you will get to see how we are decoupling several modules. It will be a simple implementation, but it will get you an understanding. So we can create a class named event bus, and we can have a constructor. And what will this constructor consist of? So it will consist of, let me just open. Yeah. So as you can see, this is the event class, and it will be consisting of an unique ID and map. You can also keep type, but for now I am considering the type not in the class, but you can consider this type if it's needed. So it will be having an unique ID and the map, right? So let's say for the map, I name it as listeners, And for unique ID, I can maintain something like, let's say, event counter, which will get incremented for every event, although these results it wouldn't be applicable for larger application. In that case, you might want to use something like EU ID or something nano ID and so on. But in this case, I'll be using a simple event counter, which will be incremented with 1. So we have the map here and we have the event counter here. And now let's define the subscribe method here. So subscribe will be having an event and its corresponding callback here. And first of all, I need to check if the event here is already present in the listener. If it is not present, we need to create a new one in the map. So let me just create this dot listeners dot has event. If it is not present, I want to create a new event here dot set, and I want to create an empty array here, right? So this will only be happening when there's the event here is not present already in the map. And then I can push this particular callback in this array. So these callbacks are essentially the handlers that I was showing you earlier, and I will do a get here for that event. And when I'm getting that event, I'll be pushing the handler or the callback to that. So let me just show you what I mean by this particular one. So you can imagine it's something like this. Let me just show you here. So as you can see, we have a map named listeners and we have event counters, which is set to 0 initially. So let's say I have an event named cart. Okay. So in the map, what I'm doing is, if this map consists of cart, which is not initially present, so I'll be setting a new key here named cart, and it will be mapped with an empty array here, right? Then let's say for this cart, I have a handler named add to cart, which I will pass later on. But in this, let's say this is the handler here, which is the callback. So callback and handlers, I'm using it interchangeably, as you can guess. So add to cart is a callback here, and let's say after this is created, this line will be executed, which is firstly it is getting that event listeners.get of cart, right? This is a listeners.get of cart is an empty array here, which is the value. So here I will be pushing this particular callback, which is if I am to summarize, it will look like something like this. Cart will be mapped to add to cart. This is a function essentially. So this will look like this. This is a key here, which is the event. This is a handler here, which is a callback, which is a value. Basically, the map will look something like this is the event, and it will be mapped with the add to cart, which is the callback. I hope you get this. So why are we using a map here? Because as I said before, subscribing means I'm subscribing to that particular event so that I am notified when the event occurs, right? So I need to maintain a map so that whenever this event occurs, I am getting this callback. I am getting this callback so that I can trigger this callback, right? So this is the purpose of subscribe. And after subscribe, we can define the publish method, which will publish the event along with the data, right? So let's say I define here publish event and data, and we can define multiple stuff in the data. One of them can be a timestamp. So timestamp would represent the moment in time when the event occurred. As for use cases, these can be used for logging and as well as debugging purposes. It can help us track the event and we can get the sequence of events over the time. And if some events have like time sensitive aspects, these timestamps would help us in managing maybe some time related logic or determining the ordering of events. So I can consider timestamp, which is quite commonly used, and I can use new date. I can have the 2 ISO string here. So this is the unique ID, and so I also need to keep the event information, which is the data. So event data maybe, and I can just create an object with event data, and then I have the timestamp here. And here, as you can guess, we initially declared an event counter, which is the ID, and we can define a property named ID, and we can just increase this event counter, right? So event data will be having the particular event's name and the data associated with it. Let's say the event is cart and the data is something like your product has been shipped. So I'm keeping the whole data, like here it will be cart, here it will be your product has been shipped, the timestamp for when the event occurs, and then unique ID to identify this particular event that has been published. So I can also just show you here event data. It will logged when I call this. So yeah. So after that, I also need to let me just open my SkyDraw. Let's say I publish an event E1. Let's say it is cart, right? Let's say I publish this cart with some data. Maybe there are some data that you can think of. So after this is published, this is the event bus, right? And I have the subscribers here. So I am notified to that particular event. So whenever this cart event is published, I also need to trigger the particular callback whenever I am getting this cart event, because as you can see, the cart event has been dispatched in the bus, and now subscriber is ready to trigger the particular callback because cart has been registered and published in the event bus, right? So I need to loop through each of the particular callbacks for that particular event. Let's say there is a callback named add to cart, right? I need to make sure that I am triggering this here whenever I'm publishing, right? Because I'm already subscribed to this particular event. So let's do the same. And it might be possible that for a particular event there are multiple callbacks, because as you can see, we have declared an array here. So there can be multiple handlers that we want to execute. Let's say I want to execute for event card, I want to execute handler 1 and handler 2. So I need to make sure both of them are triggered, right? So I need to loop through this entire array and need to trigger all the callbacks associated with that particular event. So if this dot listeners is present, if event is present in the listeners, then I need to make sure listeners dot get, I'm getting the particular event, and which is the key here. Then I am looping through each of the values in the array, right? So we can do a for each. As you can see, we are doing a chaining here. And for each of these are array of callbacks. So let's say for each callback, what I can do is I can trigger them, right? So I will be triggering with this event data, right? So whenever I am subscribed to that particular event and I'm getting the event published, I will be triggering all the callbacks that are associated with that particular event. So when I complete this entire code, you will be getting it. You will be understanding what I mean here if you are not getting it right now. So yeah, so our class is complete, I guess, and we can instantiate an object here. Event bus equals to new event bus. So we have instantiated the object. Now we need to do some stuff here. So considering we are in an e-commerce software architecture, and we need to make sure there are two modules, maybe shopping cart and another maybe user notification module. So there can be two modules. In this case, I'm taking two modules. One is a shopping cart module and another is a user notification module. So let me just define here shopping cart module, and I can just create a handler here, add to cart handler, which will be taking the event data, and let's say I pass an object here. So I am thinking of passing an object here to be shown in the add to cart handler. So you can pass any other thing that you want to, but in this case I want to consider this like a JSON that I am getting, right? So we need to stringify that because we are passing an object here. So let's say let me just item here, or item string that I am getting. This will basically be stringifying this event data. So JSON.stringify. Again, why are we doing this? Because we are passing an object here which we need to stringify to show in the console, which I will log in this. So it's like event data, and I can just say console log, and maybe I can write shopping cart, and I can show this item string. This is like a small module, nothing fancy. I might even change this when I declare and pass the arguments. So yeah, so the handler has been created, which is basically, as you can see, is a callback here. So the handler has been created, and correspondingly I need to do a subscription. So const cart subscription goes to event bus, and I need to subscribe to that particular event. Maybe add to cart is the event name here. As I showed before, this is the event name, and if I show you subscribe, as you might remember, it takes event and the callback. So add to cart handler is a callback here, right? So yeah, so this the module, and we can declare another module here, maybe the user notification module that I was saying before, user notification module, right? So function show notification handler, it will be taking the event data as usual, and similarly we can just do the same. I'm also obviously passing the object here, so I need to stringify this so that I can log it. So item string json.stringify, and I can do this event data here. I can stringify this event data, and I can just show notification, and I can show here the notification that I am passing the data. And of course I need to subscribe, so const notification, notification subscription equals to event bus dot subscribe, and I can pass the event here, maybe show notification, and I can pass the handler, which is, if I go to subscribe, you can see it takes the event, which is show notification, and the callback, which is the handler here. And I'm mapping the event show notification with its corresponding handler named show notification handler. So I guess I can show you the map here. So let me just print the map here. Console, since our map is populated, so listeners is the map here, and I will get it from event bus object. So let me just run this event bus. So as you can see, add to cart is being mapped with a function named add to cart handler, and show notification event is mapped with show notification handler. So this is how this map looks like, and we can make sure that every time this event is associated with this particular handler only. So yeah, so now we need to publish these events, right? Because we are already subscribed now. So as you can see, we are subscribing to this particular event here. We are subscribing. So user notification module is subscribed to the event bus, and add to cart module is subscribed to the event bus. But now we need to publish the event so that these are notified, and we can just show in the console the data. So let's say publishing here. I had to access event bus dot publish. Let's see what it takes again. So it takes the event and the data, right? So the event is add to cart, which is mapped here. Yeah, so let's say I have something like data, which will determine the item that is in the cart. Let's say MX Master 2S, the mouse that I'm using right now. So this is a product that is in the cart, and similarly, whenever we are doing an add to cart, we are also notifying the user that your items notification has arrived. I mean, obviously it doesn't concurrently happen because it depends upon your own choice. So we can also declare another publish here, and we'll be publishing an event for the notification. Publish, and the name is show notification, and maybe we can just show something like your item is shipped, right? So let me just run it because it looks fine to me. It should show us the data here. Yeah, so if I just show you publish, if I just show you, I have console.event data. So as you can see, I have an event named add to cart, which has a data property, here, which is the item, and a timestamp, a unique timestamp with a unique ID. Then we also have another event named show notification. Okay, so we can just get data here that I am showing. So as you can see, event data is the whole object, right? So we can just show the data property here. So in this case, it is your item is shipped, and similarly for add to cart, this is the product. So yeah, so we are getting, we can also omit this here. So if I run it again, so as you can see, there are two items in the shopping cart. We are having the product that I have added to cart, and the notification is from the another module, which is like a notification that I am getting. And yeah, so we can just simulate something here, like what happens in a real world system. Let's say there are let's say these are like in a continuous manner, and it is happening at every second an user clicks on add to cart button. So let me just simulate here, set interval, and I can just give like 1 second maybe, or 2 seconds, 3 seconds, okay, and put this inside. Maybe I can just do a separation. After 3 seconds, yeah, we are getting this data. Yeah, so you can just imagine these are like happening in real time, and these two are different modules which are emitting two different events to the event bus, and which is basically publishing two different events to the event bus, and we are subscribed to that particular event. So subscribe will be getting that particular event's callbacks and will be triggering them, and the triggering is done here in the publish. So whenever we are publishing an event, we are looping through that particular event's key, and we are fetching the values. The values are the callbacks, and we are triggering each of the callback for that particular event data. So let me just summarize now everything. So first of all, we are creating an event class, event bus class, and which is having a map and event counter ID. So as I said, map is basically mapping the particular event to a number of callbacks. So it's like a one-to-many relationship, not entirely, but yeah, you can imagine like that. So an event is mapped with several other handlers that will be triggered whenever we publish an event. Let's say we publish an event add to cart, so there can be several handlers like show profile data or show personal data. So there can be several handlers that will be triggered whenever we are publishing an event, so named E1, let's say. So the event E1 is mapped with an array of callbacks that will be triggered whenever we are publishing the event E1. So let me just write here. Example, we are publishing an event E1. Then what's gonna happen is E1 with its handlers, which are the callbacks. Every time the event is published, I will trigger the callbacks mapped with the event. So this is what is happening, and this is why we need the map, and we are declaring a unique ID here, which will not be in the case of a real world software system. So we are just keeping an event counter here, and then we are defining subscribe for a method here, which is taking the event and the callback. So the event is E1 and the callbacks are pushed like into the array for that particular event. So here E1 is the key, which is mapped with values, which is mapped with the callbacks, which are the values. So initially, if for E1 there is no if the key E1 isn't present at first, we are setting a new key with the named key event here, which is E1. We are getting a new key E1 with an empty array. So here E1 will be mapped with an empty array here, and then we are pushing the particular callback. Maybe here we have something add to cart maybe. So we are So this is like this is a function obviously. So E1 is mapped with callbacks here. So there can be other callbacks too, like ABCD, XYZ, and so on and so forth. So for each event, for an unique event, there will be several other callbacks which will be triggering whenever we are publishing the event. So I guess you understood it. So yeah, this is how subscribe works. Then we are publishing the event. So how are we doing that? So for publishing that event, we need to show some data, some unique data with that we want to show in the web page or so on. In this case, it is in the console. So we are declaring the publish method here, which is accepting the event and the data, and then we are declaring, we are getting a timestamp, which is like a unique parameter here. You can omit it obviously, but we need it because there are instances where we need to maintain the ordering whenever we are pulling the data. So there are other stuff that are involved. For now, we are doing we are keeping timestamp here, and then we are making a new object here. We are creating a new object here with properties of event, data, timestamp, and it will also have ID. ID here is every time getting incremented by 1. So yeah, so after that, after we are initializing and populating this event data object, we are checking if this particular event, let's say E1, so let's say add to cart, if add to cart is present in the listeners. If it is present in the listeners, we are looping through each of the mapped events callbacks, and we are triggering them. So in this case, E1 is mapped with, let's say it's add to cart, and then something else like show payment page, like this. So it will loop through each of these elements and it will trigger for each of them, because for a particular event there can be multiple functions that should run, right? So yeah, so this is what it is doing. So first I am getting this event, which is E1. So I am getting the particular key, and here I am getting the values that are associated with the key. So the value is obviously the array here, and for each element in the array I am looping through each element. So CB here represents add to cart, then it loops again, and CB then represents show payment page, and so on. And then I am triggering them. So so I'm passing this. So let's say this is the original function, and so I will be passing add to cart, then I'm passing the event data here. So what it is happening is add to cart will be triggered with the value of event data, right? So add to cart is defined here, add to cart handler. So it will be triggering this, and same goes for the other stuff that might be present. So yeah, so after we have declared the class, we are instantiating an object. Then we have created 2 modules to understand and simulate a real world example here. So we are considering an e-commerce system which is having add to cart handler, and of course, as I showed here, add to cart will be called with event data, right? So we are calling this particular callback here, which is getting triggered here. So it is basically add to cart handler. So add to cart handler is triggered when add to cart event is emitted. So let's go through this particular function. So first of all, we are getting this particular object and we are stringifying it, and then we are just logging this particular thing, and after the callback has been defined, so we are basically subscribing to that particular event and its associated callback here. And similarly, we are doing the same for notification. We are just getting the object and stringifying it, and then we are subscribing to that particular event. So this is the event name and this is the handler, and I'm just simulating a publish system here. Let's say in every 3 seconds I'm publishing an event add to cart. Imagine it like millions of users clicking on the add to cart button on your app, on your Amazon app or something, and whenever I'm publishing this event, I'm passing a data that will be shown. Let's say here it is MX master 2s and so on. And similarly, I'm doing the same for notification, and I'm showing, okay, your item is shipped. Of course, this will be different for in a real world scenario, but this is how it looks like. So yeah, this is like a summary of event bus, and there are other concepts in the event bus. First of all, as I said before, it is like it is like a pops-up system, pops-up design pattern that is quite popularly followed in software engineering. And generally, event bus is a distributed system. There can be several others working on thread pools, keeping counts of each, and so there can be topics, right? So topics are a thing that can be used for particular event association, and there is the concept of push and pull from the event that I'm getting, that I want to get, and the ordering that I said here. And there are other stuff like let's say I have an event that has already been in the event bus and I'm getting the event again. So what should the event bus do in that case? So there comes the concept of idempotency, and there is also the concept of dead letter queue, which is, let's say I'm not getting an acknowledgement, so I'm doing a retry. So yeah, there are other stuff that you might want to check on, but this is like a simple implementation of event bus. So yeah, that will be it from my side, and I'll see you in the next one.